This is question 9b and c from chapter 1a. The question asks us to, sorry I've lost it now, put root 2 plus I first in polar form and then in standard form. So first of all, if I write that out, I can say, I'll draw a little diagram to help. So this is our real axis, this is our imaginary axis, and what I'm looking at is there's 2 along the real axis and then 1 on the imaginary axis. So first of all, I'm going to express 2 plus I, and then we'll worry about the power of to 1/2, because this can be written as 2 plus I to the power of 1/2. So we need to work out what this angle theta is. So the rule is that tan theta is equal to opposite over adjacent. So theta is going to be the inverse tan of 1 over 2. And that works out to 0.46, remembering to make sure that the calculator is in radians. And now we need to work out r, which is that length of the line. So using our Pythagoras rule, basically, we'll have x squared plus y squared. So 2 squared plus 1 squared, and that gives us the square root of 5, which can be written as 2.24. So now I can say that 2 plus I is equal to 2.24 cis 0.46. So that part's in polar form. Now, because we've actually got to find the square root of 2 plus I, we can say that 2 plus I to the 1/2 is equal to 2.24 cis 0.46 to 1/2. So now we need to use the Moivre theory. So that's going to say that that's equal to 2.24 to the power of 1/2 cis, and then we have 1/2 times 0.46, and that will then give us 1.5 cis 0.23. So that's my answer in polar form. Then question C asks you to find the same thing but in standard form. So in that case there, if I call this Z, I can say that Z is going to be equal to 1.5 cos 0.23 plus 1.5, I'll put the I there, sine 0.23, which is where the cis comes from your cos, the I and the sine. So if we work out 1.5 cos 0.23, we get 1.46, and work out 1.5 times sine 0.23, we get 0.34i. So that would be my answer in standard form.